Yaskawa.
Hello, this is Doug Meyer with Yaskawa America, and today we've developed this quick e-learning video just to show how to demonstrate some of the example camming files that have been created for the MP2300Siec. To make it easy, both of these programs, we're going to look at two programs today, and both of them have been developed to be used on the standard MP2300Siec demo kit for ease of configuration. So this kit should be set up with the MP2300Siec controller. The config switch should be on in the upper bank of diff switches, and the E-init switch should be on in the lower bank to set the IEC controller to the default address of 192.168.1.1. Also, the configuration assumes that the left Sigma 5 amplifier is set to address 1 and the right Sigma 5 amplifier is set to address 2. Over on the switch panel, you want to make sure that all 8 of your digital inputs are set to the off position, which is down, and that both axes SI1 and SI2 are set to the up position in order to disable the end of travel limit switches. In these examples, the left axis, or axis number 1 on the left, will be the slave axis, and we're going to use axis 2 on the right as the master axis. Taking a look at the files that you have available as you download them from the website, again, there's two programs. One is called Dual Cam Swap, which demonstrates how to change cam profiles on the fly, and the other one, which is called Cam Shift Offset Scale, and it goes through the basic features and effects of when you apply a cam shift and a cam offset and a cam scale. Also on here are the cam files in a CSV format. We have a simple one-way cam and a simple two-way cam. Also, the actual data files have been provided so that you could load these into Yaskawa's cam tool. And one of the easiest ways that we've found to download these programs, especially in this demo format, is to actually download the project archive. As far as the whole procedure goes, we're going to show how to use the web interface to download the project archive. Then we're going to use MotionWorks IEC Express to open the program and start the debug mode so we can monitor the effect. And then we'll show you how to run the demo using the demo switches. All right, so first, to download the project archive, we're going to navigate to the web page, and in this case it's located at 192.168.1.1, and we need to log in as an administrator. So the login ID is capital A and then a lowercase d-m-i-n for admin. The password is MP2300 capital S, all in caps. And then you see that there's additional menus that show up. So what we're going to do is go into the project archive, and if you had been running something else with this particular controller, you'll see a lot of project archive files. So we're going to delete all those files to clear that out. There's a little warning because you can't go back once you erase them. So now we have a clear controller, and we're going to install our demo code archive. You do that up here by under the install archive where you browse, and we're going to navigate to our files. We have them here in the ELV example code files, and we're going to take a look at the shift offset scale program first. So we're going to select that archive. It's a zipped file. We're going to hit upload, and it goes through the process of transferring everything. Now the benefit of doing it in this manner is that not only is the project code sent to the controller, but also the cam files have been already downloaded for you, as well as the configuration files that you need. In this case, I've also, as I stored the project initially, stored the source code. So theoretically, you would be able to take this one zip file, download it here to the controller, and then all of your files will be here. And if we take a look through here, we've got our simple one-way. This is the CSV file that we'll be using. We also have a simple two-way. We have source files, and we have our axis, hardware, and I/O configuration files all in here, as well as our drive parameter files. So everything is there in one fell swoop. Last thing to do is to reboot the controller. You can do that software-wise, or you can physically cycle power. I'm going to do it software-wise by rebooting the controller right here. After that, then we're ready to open up our program and run the unit. Okay, we're going to switch now to MotionWorks IEC Express and open up our project file. So we click on Open Project and we navigate into the folder. See, this is where I have these programs stored, and we're going to start with our Shift Offset Scale program. It's a zip file, and it'll ask if you want to unzip it to the same folder, and so we'll click Yes. Even though you get this message, you may get this if it already exists. We're going to overwrite by saying Yes to all. And you may also get this firmware library message. We're going to choose Skip. So now the program opens up, and we have several POUs already stored in here: revision history, init, main, and then CAM. The revision history is a place that shows some of the notes. Again, it kind of demonstrates here what you can put in your programs as far as explanation goes. So it describes what the program is going to do, and revisions describes the I/O. So as we go through here, we'll find that digital input 0 will enable both axes. Digital input 1 will jog the master. 2 will engage. 3 will disengage. And so on. 4 executes a cam shift. 5 an offset. And 6 a scale factor. And if you do get any alarms, say you activate the limit or something like that, digital input 7 resets the alarms. So go ahead and click on the Make button to compile the program. And we'll take a look at our main routine first. So let's just take a look through the code just so you know quickly what is happening. Input 0 will enable the axes. And that's shown if we flip up 0. We'll see that now the axes have torque on it. We'll hit our debug mode so we can see so we can get our status. Enables both axes and sets position to 0. Down here is where we have a MC move velocity PLC open block set for axis 2. So when we turn on input 1, see the axis starts moving at a speed of 360 degrees per second, or 1 rev per second. So now our master is moving. Now let's take a look at what's happening in the cam routine. In the cam routine, as soon as the axis gets enabled, then it loads the cam file, the pre-selected cam file. And in this case, it's pointing to the simple two-way.csv file that's already been loaded. The simple cam in block is a engage block. So when I input, if I toggle input 2, it starts running the cam. Now the cam in block is a rising edge, so it only takes effect on the rising edge of the execute. So now we see that our cam is active. If I want to disengage the cam, input 3 will disengage the cam. Both of these are set to use the type engage position. So it'll engage the position at the master position 0, and it'll disengage at master position 0. So again, I'll start that cam moving. To perform a cam shift, we put in a shift distance, and the adjust method is over a certain master distance, and the master distance is put in here as 180 degrees. So what shift does is shift the slave in position to the master. Right now you can see that as the master is at 0, or up at its very topmost position, that's where the slave executes its cycle. Now with a shift of 90 degrees, if I flip up input 4, you see that the slave just sped up, and now it's going at a cycle in relation with the master over here at 90 degrees. If I do it again, you see that now it executes its cycle, but it's around the master down at 180 degrees. So we're shifting the relationship between the master and the slave. But note that the cam cycle is still going around a 0 point up at the top. So if I do this 4 times, you see that it eventually comes around and is back in phase with the slave up at 0 degrees. Okay, so to give you a little better graphic example of the effect of shift, I've set my shift distance to 180 degrees, and I'm going to open up the logic analyzer. And I've captured a trace here that shows the relationship between the master on the top in the blue and the slave position in red. And I can pull a cursor over, and you see initially that the slave, as it goes from 0 to 360 degrees and then back to 0 again, the 0 point of the slave also corresponds to the 0 point of my master, where I start at 0, go out 360, and come back in a nice sinusoidal fashion. And then, you see, midway through, we execute the shift, and the shift takes place over 180 degrees of the master. And post-shift, we see that the relationship between the master and slave has changed. The master, at 0, is now the 180 degree point of a slave, and so on. So this shows a nice graphical example of the effect of the shift. Now let's contrast that with the scale factor. Scale factor is set right here. So if I flip on input number 6, it'll change the scale, which is currently set at 50%. So the effect is that the cam only goes out and back half of what it used to. So instead of going 1 full rev out and 1 full rev back, it only goes half a rev out and half a rev back. If I want to change this, then I can double click on this and overwrite the value to something else. If I want it to go 200 or twice as far as it was going before, then I set my new factor and I retoggle input 6. Now it goes out 2 revs and comes back 2 revs all over the same master cycle. For convenience, I'll set this back at 100% and retoggle input 6. Okay, now we're back where we started. To give you a better graphical example of what happens with the cam scale block, again, I've taken a logic analyzer trace showing my master cycle at 0 to 360 degrees, and initially I was at 100% full scale. Midway through, I changed the scale factor. It changes very smoothly at the 0 position, and now it's only going 50% of what it was. So it'll take our original cam output and either shrink it or expand it over the same master cycle. My 0 position is still at 0. It's just going half as far. Now let's take a look at the slave offset. What the slave offset does is keep the same relation between master and slave, but it's actually going to move the 0 point of the slave. So here I have an offset distance right now of 180 degrees. So if I toggle input 5, you'll see this take effect. Okay, and you see it took effect, and now our slave 0 point is at the bottom, cycling back and forth between the bottom. So I've actually moved the position where the cam is cycling. Now this is an absolute number. So if I toggled it again at 180 degrees, it would stay where it's at. So I'm going to set this to 90 degrees and toggle it. And you'll see that now it moves and it's at the 90 degree position. And if I want to put it back where I started, I put an absolute cam offset of 0. And when I retoggle this, now I'm back where I started at 0 offset in relation to the master. And finally, to give you a better graphical example of what happens with the slave offset block, You can see from our graph here, as our cam master goes from 0 to 360 degrees, at some point we do a cam offset, and it actually moved the location of the slave by 180 degrees. So where the 0 point used to be here, now the 0 point is up here at this level, and it's oscillating over the full cycle, just at a different starting location. So by going through these simple examples here in these 3 blocks, cam engage, cam shift, slave offset, and cam scale, we can accomplish a wide variety of applications. To disengage, I'll click up input 3, and then I can stop my master from moving. And when I disable, then it activates this release cam table. This is kind of important because when the cam table is loaded with cam file select, it puts it into a memory area. And if we were to retoggle that, then it would take up more and more and more of that memory area. So eventually, you could consume all of your memory space. So basically what we've simply done is to, when everything is enabled and camming is possible, we load the cam file, and then when we disable, we just clear out that memory space to make it available again so that we never run out. Now we'll take a look at the other program, which will demonstrate how we can shift cam tables or change cam tables on the fly. So I'm going to close this program out. I'm going to exit debug mode and then close this program out. To change programs this time, since I already have a good configuration and I have my cam files already in place, I'm just going to open the other project and download it through the normal utility. So I'm going to open project, and this time I'm going to choose dual cam swap real master. Again, I'm going to unzip it into the same directory, overwrite my PLC open toolbox, and skip the firmware library. Okay, so this program shows how to load and run simple cam files, and it can switch between 2 predefined cams on the fly. So the digital input 4 switch actually selects your cam. So the same as before, input 0 enables the axes, input 1 will jog the master, 2 will engage, and 3 will disengage, and then 4 will be our cam file select, and it'll select either our 2-way cam or our simple 1-way cam. So let's take a look at this program. So now that it's open, I'm going to compile it by hitting make. I'm then going to open my project download dialog box. First thing, I'll stop the controller and then click on download, and I'm going to download the project. It'll come up with a dialog box noting the fact that, hey, I'm going to download a new program. What I have stored is something different. So is it okay to overwrite? I'm going to choose yes. After downloading, I'm going to do a cold start. And as before, I will activate the debug mode so I can see what's happening. Okay, over here on the demo kit now, it's ready to go. And by the way, I like to start these out up at 0 position. So now you can enable the axes. We can start our master moving again. Engage our cam with input 2. Now input 4 is our selector. So right now it's running the 2-way cam. If I flip this up and retoggle my cam in block, it now runs the 1-way cam on the fly. So the way it does this is we have 2 cam files selected. When everything is enabled, we load cam file, our first cam file, and it gives a cam table ID number. And when we point it to our second one, we get a different number. Then here the selector will move either the first cam table ID or the second cam table ID into a common variable. In this case, use this cam file. And then when we do our cam engage, it's that cam file ID number that goes here with the engaged position. So as we switch the state of input 4, you see that the state, the cam table ID is passed into use this cam file. So right now we're doing our one-way cam. Let's switch back to our two-way cam. It says use this one, and when I retoggle the execute, input number 2, see that it immediately changes cam tables at this position, position 0. And just like before, after we disengage and then stop everything and disable, it releases the cam table memory space. So now we've demonstrated to you the basic features of how to select cam files that have been preloaded as CSV files, and these can be created either by Yaskawa's CAM tool, or they can be created by an Excel spreadsheet and then transferred to the control. We've shown how to do a simple cam scale function, a cam shift function, and a slave offset function, and we've shown how to simply adjust cam files on the fly. Well, this concludes our e-learning video on these simple example code files for IEC camming. We hope it's been of value to you and it helps you in your applications. Thank you.